And this is Worksheet 10A for the Math 2 course. And another look at a square root in real life. Now, here we're supposed to find the domain of each function. And the shortcut that I gave you was to realize that the parentheses are the roof. And that we should only be looking at what's under the roof. This guy greater than or equal to 0. And then solve for x. Remember, the rules say that you only flip the symbol when you're multiplying or dividing by a negative number. Adding and subtracting doesn't count. Dividing by a positive doesn't count. So the symbol stays the same. And so it's greater than or equal to -2. So we're going to say that the domain starts at -2. It's equal to -2, but it goes on to infinity. Now, this guy over here, because 4x is the only thing that's under the roof, we're ignoring the 10. We're just going to say 4x greater than or equal to 0. When I divide by 4 to get x by itself, 0 divided by 4 is still 0. So x is greater than or equal to 0. Our domain is going to start at 0 and go on to infinity. Here, the brackets, the square brackets, mean that everything inside is under the roof, including the parenthesis. So we're going to say 2 times x minus 4 is greater than or equal to 0. And here, I think I showed you this in the notes. Rather than distribute the 2 and then undo all of that, you're trying to get x by itself. And 0 divided by 2 is still 0. You're going to wind up with that, which means that my domain starts at +4 and goes up. Now, the guy over here, we're going to say 6x greater than or equal to 0, which we kind of ran into this situation earlier. We wind up with 0 being the starting place, and then goes on to infinity. Now, I had said during class and during the video that you can skip these 2. I'm not asking you to do any t-charts. All right, when we look at this, what units are involved in this problem? Well, there's feet, and then there's feet per second. To define the quantities and variables you would use to model this situation. So we're talking about a relationship between feet and feet per second. Now, just in looking at this curve, it appears to be a square root curve, not a traditional one. It's got some stretching or flattening going on, but the curve is in the same general direction. Now, let's see, what type of function does this graph represent? One, the fact that it's only positive. That's a telltale sign. The other is that it has a parabola-like curve. Those are your 2 dead giveaways that this is going to wind up being a square root curve. All right. Now, I've really kind of buzzed through this, and we didn't really look at what it's looking at here. It is showing that there is a relationship between the length of the leg of an animal, how many feet long the leg is, and the walking speed of an animal, how many feet per second they can walk. And obviously the longer the leg, the faster they can walk, but that's not a straight line. As a matter of fact, the longer the leg gets, the speed tends to grow less. All right, so which one is the correct function for this graph? Now, we can look at these and we can tell that there are certain things wrong with some of these. For instance, this guy should move the vertex left by 64 units, which obviously it's not. In the graph, the vertex is at 0, 0. So it's not him. And when I look at this guy, 2x squared, that graph should be looking like that, not sideways. So the only one that really makes sense here is going to be this guy. Now, if I start plugging in some of these numbers, do I know that 8 equals square root of 32 times 2, which is 64? Yes. If I put a 16 here and say 32 times 16, no, excuse me, 32 times 8. The 8 goes here, the 16 goes there. 32 times 8 is 256, which square root of 256 is 16. So far these guys are matching up. And of course, if you put a 0 in both places, that's going to work too. So that appears to be the correct function to go along with the graph. Now we're going to use that. A T-Rex has a leg length of 20 feet. So what would his walking speed? Well, we had the speed equals square root of 32 times length, times the length of the leg. Well, if we know that the length of the leg is 20, that's the square root of 640, which according to my handy and dandy calculator, square root 640 is 25.3 roughly. Now understand something. If you've been in my classroom, it is a fairly traditional classroom. It is about 25 feet deep from the hallway to the windows, and it's about 30 feet long. 25 feet deep is, well, this is 25.3 feet per second. Imagine a T-Rex that was walking, and he could walk the distance from the front to the back of the classroom in 1 second. Have the middle of his center of gravity move from the front to the back of the classroom in 1 second flat. That's getting it. That's moving. You could actually do the calculations to work it up to how many miles per hour is that. But anyway, all right, that's the end of the worksheet. I will make the comment right here that your Kahoot, you would probably find it more beneficial to spend time on the notes for the Kahoot, because the Kahoot is probably, we're going to have some domain problems, and we're probably, just like the notes had a formula, and what if they give you this, can you find that, and what if they give you that, can you find this? I am going to do that on the Kahoot quiz, so it might be more beneficial to take a good hard look at the notes before you get to class.